Hello everyone. So today we are going to study a new topic, and that is definite integrals. Definite integrals. So when we talk of definite integrals, the first thing that comes in our mind is the fundamental theorem of calculus, wherein we have got a function f of x, that is small f of x, is a function which is continuous. This function is continuous function. What do we mean by continuous function? A continuous function is such that it doesn't have any breaks in between. No lines are breaking here, no curve is breaking. So this function is called as a continuous function. Fine. Now, if this function is continuous on an interval, that is a, which is the lower limit, and b, which is the upper limit. So a is the lower bound and b is the upper bound of this function. Y is equal to f of x. So this function is said to be continuous on a, b, where a and b are also included. What can we say about the antiderivative of f of x? Antiderivative of f of x, we will call it as capital F of x here. Now you know that antiderivative is just the integration of f of x. So we will write it as integration of f of x dx from lower limit a to the upper limit b. This would give me something which is called as my definite integral. That is, I would get here f of x plus c in the first place, and then I would have to put the value of a and b in such a way that I am subtracting this value from this value of the function. Fine. So let's do it. F of b plus c minus f of a plus c. Now, let us see here, what am I getting? I am getting something like this. F of b minus f of a, where c and c are going to get cancelled. So clearly we can see that in a definite integral, we do not have a constant c. It is free of that constant, and that's why I'm not putting it here, because it is getting cancelled in the subtraction process. So I hope you understood up to here, and then now we can proceed further. But before proceeding further, I would like to ask you one question. What is the difference between a definite integral and an indefinite integral? Okay, so previously when you learned about indefinite integral, what was the integration of that? It was f of x dx is equal to capital F of x plus c. Alright? Now, if we have to see the right hand side of it, it's clear that it is a function. The answer of this integration is a function. If we are putting the lower limits and the upper limits, the lower limit is a, the upper limit is b. If we are putting that, what are we going to get here? We will get f of b minus f of a. So here, my answer is not a function. My answer would be a number. It is not a function, it's a number, because we are putting upper limit and the lower limit. I hope it's clear for you. Let us try and solve some questions which are related to my definite integrals. Okay, so now that you all know the formula, solving questions would be a bit easier for you. Okay, so I have my first question, that is this one, integration of 1 to 2 x cubed minus 4x plus 5 dx. Right, now look carefully at this question. It has got two numbers. 2 is the upper limit and 1 is the lower limit. So what are we going to do with this? We will later substitute that. Okay, so let's begin. Now, you know that if I have got an integral like this, integration of x raised to n dx, it's going to be x raised to n plus 1 divided by n plus 1 plus c. So we are going to use the same thing here for x raised to 3. How will I write my x raised to 3? I would have to write it like x raised to 3 plus 1 divided by 3 plus 1. Similarly, it goes for minus 4x. Note that x has the power 1 here. So what will this become? minus 4 times x raised to 1 plus 1 divided by 1 plus 1. And where is x here? We don't have an x here, so the power of x would be considered as 0 here. And that's why we are going to put 5 times x raised to 0 plus 1 divided by 0 plus 1. Now let's simplify all this. Just wait a minute. Where is the lower limit 1 and upper limit 2? Where has it gone? So what we have to see is we are going to substitute that at the end. So we can write it here. In the brackets, I'm writing here, after the square brackets, I'm writing 1, and here I'm writing 2. Alright? So now let's simplify this. You have to just do x raised to 4 divided by 4 minus 4x squared divided by 2 plus 5x divided by 1. Let's simplify this. This would give me 2 1s and 2 2's here. That's it. I'm going to again add my lower limit and upper limit because I have not yet substituted it in the answer. Fine. So after adding the upper limit and the lower limit, what will I get the answer as? Now your substitution process should start. Okay, let me write the final answer here. X raised to 4 by 4 minus 2x squared plus 5x. So it has to be lower limit 2, upper limit. So lower limit is 1 and upper limit is 2. Now let's substitute here. So first we have to do the upper limit and minus the lower limit. So we will substitute the value of upper limit in this function. Okay, let's do that. It is going to be x raised to 4 by 4, that means 2 raised to 4 by 4 minus 2 times 2 square plus 5 times 2, alright, minus 1 raised to 4 by 4 minus 2 times 1 square plus 5 times 1. Okay, so note that we have substituted the value of 2 and substituted the value of 1 and put a negative sign in between after evaluating this limit into this function. Fine. So what is the answer that we're going to get? The answer is 6 minus 3 raised to 1 by 4. 3 times 1 by 4 is equal to 11 by 4. Alright, 11 by 4 is my answer. This is my final answer. It's 11 by 4. Okay, so now that we have done one question, I hope you might have got some confidence in finding out the definite integral of a particular function. Fine. So now let's move to the next one. And the next question, we will take it from square roots. Okay, so the B part of the question, 1 to 4, 2 root x plus 3 by x dx. Okay, so how will you evaluate this limit? Now, whenever you see a square root, please try to make that square root into a power, alright, so that it's easy for you to find the integral of that function. So, you know that root x is nothing but x raised to 2, x raised to 2 or x raised to 1 by 2. Okay, so whenever you have a square root as the power, it has to be x raised to 1 by 2. Whenever you have a cube root as the power, cube root of x, it should be x raised to 1 by 3. Alright, so we will start putting x raised to 1 by 2, x raised to 1 by 2 plus 3 divided by x. Now, remember that 1 by x is nothing but x raised to minus 1. Okay, so whenever you want to convert the denominator, want to take the denominator to the numerator, you will just put the negative power of the denominator. Fine, so I am taking this x from the denominator to the numerator, so I am putting a negative power to it. So what can we write here? We can write 3x raised to minus 1. Fine, so this is done. Now let's try to evaluate this. The integration of this thing. What would be my integration of this? Okay, so integration of 1 to 4. Now that I have to open this, I'm integrating already. I will not put this integration sign. Instead of that, I will put the square brackets. And in the square brackets, here will be my lower limit 1 and here will be my upper limit, that is 4. Fine. So 2x raised to half, what will it be? You just have to use the formula of x raised to n plus 1 divided by n plus 1. So it has to be 2 times x raised to half plus 1 divided by half plus 1 plus 3 x raised to minus 1. You know that integration of x raised to minus 1 dx is nothing but natural logarithm of x. I hope you know what is the meaning of natural logarithm. Okay, so the natural logarithm has the base e, whereas the other logarithm that we study most commonly has the base 10. Okay, now, so the logarithm with the base e is what we are going to write here, that is plus 3 ln x modulus. Okay, that means the x has to be always positive. Fine. Now is the time to simplify your answer. So if you simplify this, x raised to half plus 1 would come to be x raised to 3 by 2. So 2x raised to 3 by 2 divided by 3 by 2. This will go up. So this 2 will go up here. This 2 will go up here. And what will happen to that? This 2 went up here. So we can remove the 2 here. And the answer will be 4x raised to 3 by 2 divided by 3. Alright, so we're going to write that as the answer now. This is equal to 4 by 3 x raised to 3 by 2 plus 3 ln x, natural logarithm of x, from 1 to 4. Fine. So now let us substitute the value of the upper limit. Okay, if we substitute the value of upper limit, 4 by 3 times 4 raised to 3 by 2 raised to 3 by 2 plus 3 ln, or you can see the natural logarithm of x, that is 4. Now we have to put bracket here, minus 4 by 3 plus 3 natural logarithm of 1, which is equal to 4 by 3 times 4 raised to 3 by 2. Okay, so 4 raised to 3 by 2. What is 4 raised to 3? 4 raised to 3 is nothing but, it is 64, right? 4 raised to 3 is 64. Okay, let me show you how to do this. 4 raised to 3 is coming to be 64. So this is going to be 64 raised to 1 by 2. You know that anything raised to 1 by 2 is nothing but the square root of that. So square root of 64 is going to be your 8. So 4 by 3 times 8 plus 3 ln 4 minus 4 by 3 plus ln 1. Now I'm going to take my calculator here. So evaluate that directly from the calculator and get a number as the answer. Okay, so for this one I have got my answer as, the first one, if I am doing it from the calculator, I'm getting it as 28 over 3. And for this one, the second term, I'm getting it as 6 natural logarithm of 2. So actually it's simplified version that I have written here. I've simplified this and you can check that as well. Okay, so I hope you understood how to apply the second fundamental theorem of calculus to solve the problems of definite integrals, and you will be able to do some of the questions on your own. Thank you.